Is it audible now? Risha, Srishti, Sumit, is it audible now? And the audio is clear? You think the audio is clear? Audible as well as it's clear? Yeah. Okay. Okay. Fine. So let's do that. I think there seems to be some audio settings which have gone haywire. So I'll fix it later. Any which ways, one of the audios is working. Let's continue. Okay, let's continue. We will explore a little bit about the graphs in this chapter. So I will not take much time. So I will explore with some of the basic graphs. Not only this, there is a lot about graphs. Probably we will divide and we'll do one more lecture at a later stage. But I'm not sure how many of you have taken a look at the basic graphs of it. What I do is we'll do on-the-job training kind of, rather than trying to draw all the graphs of how the log x look like, e power x look like, x cube looks like, x square looks like, root x looks like. So when the time comes, we will explore those thoughts. So today we will explore with some of the very basic graphs to start with, pretty basics ones to start with. And once we are comfortable with it, we will come to the next level of graphs, because graphs is another thing where questions do come, but they use very basic graphs, not about any graphs that are kind of a part of IIT JEE entrance exams, not at that level. But certainly, yes, they want you to have a basic understanding of a graph. You may wonder, so why such graph basic understanding is required? When you do the microeconomics, especially, you will draw a lot of graphs. You will draw a lot of graphs for demand, supply, all that stuff. Most of it is a straight line graph, no doubt about it. But when you go into a deeper study of it, it need not be a straight line graphs. From that perspective, we kind of need to have a basic understanding of graph, because our economics teacher will not sit and teach you the graphs. He will only draw the graphs. That too on a PPT, you would have already drawn a graph. He will just show it. You should be able to understand what is that graph about, what is the point of intersection, all that stuff we should be able to understand there. From that perspective, some basic understanding of graphs is tested, right? So and that's what we kind of do in this lecture. Let's do the ground basic kind of it, and then we will proceed. That's the objective of this. Yeah. Hi Shivani, hello. Yeah, hello. So most of you know me, so just in case already now anybody logged in, will log in at a later point in view to just to understand this. I'm Belvi Srinivas. I've been working in the test prep industry since 14 years, since 2007. That's about 14 years now, in various capacities, and I especially train the students in the areas of DI, DA, LR, and QA. And if you have any short counseling requirements or short discussions or doubt clarifications, you can join this particular group. There are many already on this particular group. You can help each other wherever some assistance is required. So naturally, I'll chip in and I will try to help you there. This is one way you can connect with me. As most of you know, Unacademy offers two kinds of subscription plans. The one of them is a plus and the other one is iconic. If you're looking at one-to-one interactions, good number of one-to-one interactions, iconic will help. No interactions. We just want to have the structured course and access to the tests, etc. That's when you kind of opt for a plus subscription. So CAT 21 students, this looks a little bit of a promising batch. You can kind of take a look into it. The other batches are curated for CAT 22 or CMAT 22. These are the upcoming batches starting today or this particular week. Yes, these are the subscription plans. And yes, of course, the 1 month, 2 month kind of plans also must be available. Just check it out based on the offers. Right, so on these particular plans, you do get 10% discount when you use any of the educator codes, including my code. You get about 10% discount on the plans that are mentioned out here. So if you're CAT 21 planning to appear for CAT 21 and looking for a subscription, I would rather recommend you to go for an iconic subscription, because next 3 or 4 months you might require quite a bit of interaction. So iconic would make better sense when compared with other plans. Yeah, I already inquired with most of you. I'm sure you guys are taking the test. Probably Sumit may have to answer that. Sumit and Shivani, have you guys taken the test on Sunday? Did you guys write the test? And who else? Tejal answered, I guess. Rishav answered. Srishti answered. Shivani, you took the test. What about you, Sumit? Did you answer last time? Have you taken the test? Right, yeah, if not, you should sign out of the class. right? That's a punishment. Yeah. Anyway, I'm kidding. I'm pretty serious, but at the same time, I'm saying that, hey, it makes all the sense. Otherwise, listening to the lectures, not trying to write the test, won't make any sense. It doesn't take us anywhere. So these two activities should go hand in hand, which is very, very important. All right, good guys. Okay, good. Let's go on. So Kishan and Pranjal are joining in. Okay, that's glad. That's good. That's good. Are we all appearing for CAT 21? Anybody CAT 22 here? Good question. Rishabh is asking. Anybody for CAT 22 here? As far as I understand, you are all appearing for CAT 1 and CAT 21. Otherwise, it is too fast, right? For CAT 22, you don't have to do it at this pace. Anybody for 22 here? Anyone appearing for 22? 22, you don't have to do it at this pace, right? You don't have to do it at this pace. You will burn out before the test. So don't burn out. No need to burn out. Okay, yeah. So this happens. At times people burn out much before the exam. They lose direction. So that should not happen. You have to pace it well. You have to pace it well. You have to pace your preparation properly. Yeah, good. Nice. That's nice. That's nice. Okay, those who can already also kind of draw these particular graphs. Why don't you make an effort to draw the graph? It's like an introspection. I've just given this and I'm asking you that, hey, introspect, you kind of do it. Then I will come back and do the basics behind it. I said that we'll do a little bit of on-the-job training. So because most of you, those who are attending the lecture, also have done 11th standard math. That's an advantage when it comes to the functions and a little bit about the graphs, a little bit of algebra. Yes, it is a little bit of an advantage. So why don't you take a look at this particular question and make some sense out of this and plug your answer maybe. All right, if you get an answer, I will not say poll or something. Okay, I will give a minute. At least think about it for a minute. Don't worry, just think about it for a minute on this particular question so that it sets a momentum for us rather than I jumping into it. Let us set some momentum, then let me illustrate some of the basic graphs that we are kind of looking at today. Go ahead, think about this. Just try to put those graphs on your paper. Take a paper and try to make some sense on these particular graphs, all of that. Yeah, good, very good, very good. Yeah, very good. Right, pretty basic graphs. That's good. Very basic graphs that we have given. So there are 4 graphs here. Let me quickly illustrate them. So then we will move into the next question. Right, very basic graph. X square is equal to 4. This is one graph. Meaning of this is what? If I say x square is equal to 4, which implies x is equal to plus or minus 2. What is plus or minus 2? Let me use the red line. So maybe already this is minus 2. This is x is equal to minus 2. That is one line. So there is a point minus 2 here. This is the line which is x is equal to minus 2. It's a straight line, right? Okay. X is equal to 2 is another straight line, which is here. So this is the point 2. Let's say, hey, this is the point 0, 0, of course, right? And then this is 2. This is nothing but x is equal to 2. That is one graph you're talking about. Similarly, when you're saying that, hey, y square is equal to 4, you are saying, when you are saying y square is equal to 4, certainly y is equal to plus or minus 2. Naturally, already you will have a line here. This is y is equal to pi 2, and this is y is equal to minus 2. There is a point minus 2 here. There is a point 2 here. Therefore, this line is y is equal to 2. This line is y is equal to minus 2. Very basic graphs. All right. The next one, hey, y is equal to mod x minus 2. What is this? Y is equal to mod x minus 2. So a little bit of transformation on graphs, right? Little bit of transformation of graphs. Let's talk about it. Maybe as we get into the deeper aspect, it could be useful. So let's talk about y is equal to mod x graph. Let's say mod x, the transformation of graphs. There are many transformation, but we have four basic transformation, right? There are four basic transformation. What are the four basic transformation? Y is equal to mod x plus a. Let's say a is a positive number, mod x plus a. Y is equal to mod x minus a, mod x minus a. That's the second transformation. Say this is the number one, this is two. The third transformation is y is equal to mod x plus a. And then this is the third transformation. The fourth transformation is y is equal to mod x minus a. Right, this is mod x minus a. These are the four transformations we should be kind of aware of. These are the four basic transformation. Then you have different kinds of transformation, no doubt. So, but these are the four which are technically required for CAT. At least one should be aware of these four, because when we go to a graphical solution, so we may require this basic understanding. Okay, what is this? So if I draw the first graph, y is equal to mod x. If I draw the first graph, y is equal to mod x. So y is equal to mod x is this. This is y is equal to mod x. Okay, when I say that y is equal to mod x plus a, what is that? It is up, shift up. Shift this particular graph up by a units. Shift it up by a units here. If this point is a, so you got to shift this origin which was at 0 to the point a. That we should know. It's not that every time I plug the points and I do it. No. So you are expected to know certain transformations. Some basics transformations we should kind of know. Shift that particular graph up there. Okay. So what if all it? So let me. Y is equal to mod x minus a. Shift it down. Shift this particular graph. Take this particular graph here. There was a graph here. Shift it down by a units. Bring it down by a units. What is this? This is minus a. Go up, go down, and then coming to the other one, or coming to the other one. Hey, what about the third one? So when I say that plus x, mod x plus x, that is now shifting to the left or shifting to the right. All right, when you write plus x and minus x, that's the third one I'm talking about this. All right, when we are writing this, you are either shifting it to the left or shifting it to the right. The first graph is shifting to the left by a units. When you write plus, you are shifting to the left. All right, you are shifting it to the left. All right, you are shifting it to the left by a units, right? Yeah, you are shifting it to the right by a units. Here is this. Right, yeah. Shift it when you are saying that mod x this, x is 0, right? Y is already at hang on. Are we doing the right stuff? Yeah, that is fine. All right, yeah, shifting it to the left. Yeah, shifting it. I think I was right. I simply erased it. I was right. Shift to the left by a units. I was right. Okay, the first one is left. The second one is right. Yeah, I was right. So the last one is shifting it to the right. Last one is shifting it to the right. This transformation is shifting it to the right by a units. When you say this is the fourth graph, the fourth graph is shifting it to the right by a units. This is minus a and this is a, right? These are the four transformations. What is the four transformation? One is moving up. The first one is moving up. The second one is moving down. Look at the variations. This a is outside the mod. That is what you mean by moving up and down. When the a is shifted inside, then it will become left versus right. Then it is like left versus right. Now these are the transformations we talk about. Then comes the scaling. The other part is scaling. Sometimes we may want to understand what is that scaling. A y is equal to k times of mod x. What if I write y is equal to k times of mod x? We call this as a scaling. For example, I want to write y is equal to 2 times of mod x, let's say. That is called as a scaling. Scaling means, hey, if this is y is equal to mod x, that is 45 degrees, right? 45 degrees. When you do a scaling, it gets sharper. Y is equal to 2x means the values get sharper, right? If the k value is greater, it's a slope. It gets sharper or it gets wider. So instead of this, if I write y is equal to half of x, y is equal to half of x, then you say that, hey, it gets wider. It gets wider. That's it, wider or sharper. That is the issue of scaling. Scaling means it will have a coefficient. When it is a coefficient, we call it as a scaling. Just remember those words. We don't have to get deeper into it. As long as we're able to understand that something is getting sharper, something is getting wider, there is an issue of scaling, there is an issue of movement. All right, movement is up, movement upward, movement downward, movement to the left, movement to the right, and then scaling is nothing but making it sharper or making it wider. That's a basic understanding on transformations, what is required. Fair enough. Let's come back to this. Guys, these 4 issues are clear, everyone? These 4 issues are clear. Very, very basic. I'm sure you would know this, but we can't do any graph without having an understanding of this. These issues are clear. Yeah, now, there are many transformations which you would have studied in the 11th standard, but doesn't matter. But these are the minimum transformations which are required. Right, minimum transformation required, because we'll not be able to draw graphs at some stage. We'll not be able to put the points because cos x graph will come, e power x graph will come. We will not be able to. Rough idea of the graph is required there. Rough idea of transformation is required there. All right, coming back to this. Next one. So we have, hey, y is equal to another one. So here y is equal to mod x. Y is equal to mod x minus 2. Mod x minus 2 means what? Hey, mod x graph we already know. Do I know y is equal to mod x? Yes. Mod x minus 2 means transformation. Where is this particular transformation? This transformation is downward. All right, this transformation is downward. This is y is equal to mod x minus 2. This point goes like this, somewhere like this. Hey, this is the graph. This is the graph of y is equal to mod x minus 2. This is the graph we are talking about. Fair enough. Okay. Now what about this? Y is equal to 2 minus mod x. In other words, y is equal to minus mod x plus 2. Minus mod x plus 2. Nothing but, hey, y is equal to, what did I do? Okay, so here y is equal to, say, already know. So here if I have y is nothing but minus of mod x minus of mod x minus 2. Nothing but, hey, whatever the earlier graph you had, put it backward. Minus means now you are going backward. Here the same information, the next information, y is equal to 2 minus mod x, you got to put it upside down. Same transformation, you got to put it upside down. Nothing but, hey, this equation can also be written as y is equal to minus of mod x minus 2. This is how we can write this. Nothing but, hey, draw the graph of y is equal to mod x minus 2. Take the mirror image. Which means you already had y is equal to mod x minus 2. Its mirror image is nothing but minus of. Minus of means what? Hey, what is this minus trying to do? This minus is trying to say it's a mirror image. All right, not actually mirror image, it's a water image. Technically, actual speaking, it should be water image, because mirror image is across the vertical line. So vertical line across y-axis is called as the mirror image, across x-axis is called as the water image. The right term, whenever you have a minus sign outside, we are supposed to take the water image across the x-axis. Fair enough? Is it making sense? Everybody clear? So we spoke about the mirror image and water image also. There is no mirror image here, there is a water image here. Understood? Kind of understood? Everybody understood? We introduced all possible terms in this question. We kind of understood entire mod function. We understood water image, we understood mirror image, although I could not show mirror image in this question, but all these terms have kind of come out here. Mirror, water, everything has come out here, right? Okay, good. So now what is the region bounded by all of this? That is what question is. Okay, so you have the first line, you have the second graph, you have the third graph, and you have the fourth graph. Intersection region is what I'm looking at. Region bounded by the graphs of this is nothing but, hey, this particular region added to this particular region, added to this particular region, added to this particular region. These are the cuttings, right? So basically you're saying that bounded by the graphs, x square is equal to 4, y square is equal to 4, and lying outside the region, lying outside the bounded region means whatever I have hashed, get rid of that region. Technically, get rid of the hashed area, which means I want this area, I want this area, this area, this area, and this area. Nothing but the complete square, half of the complete square. This is the complete square. So I complete square. So because inside area is half, the hashed area is half, unhashed area is another half. You know that the length of this particular square is 4 by 4 units. This is 4 units. This entire length on the other side is 4 units. 4 plus 4, 4 into 4, 16 units. 16 units divided by 2, which is nothing but 8 units. What I want is the region which is ticked, because outside, lying outside the region bounded by the graph. So therefore we are looking at this particular region. Pretty good. All of you did well. But the point is, I quickly reminded you about about 4 transformations, 4 basic transformation functions, that is up, down, left, right. And we just kind of understood what is scaling is all about, right? How the scaling comes, which means if there is a coefficient on that we meant by the scaling. Scaling is all about. The second thing is we kind of understood whenever there is a minus sign and we write the function, it becomes the water image. At times, all it becomes the mirror image if the function comes inside. It becomes a mirror image. Fair enough. All it is the background to it. Let's carry on from here. Let's go on from here. Let's move to the next question. Now try and answer this. Everybody try and answer this particular question. Let's try this. Try this, guys. Take a minute and try this beautiful question. Take 1.5 minutes. Interpret the graph carefully. Interpret the graph carefully. Okay, good reflection time. No worries. All right, now what is right, what is wrong is a different thing. First, let's understand what is the difference between equation and inequation. Let's try and understand. What if I write y is equal to mod x? What if I write y is equal to mod x plus 2? What is the meaning of this? These are nothing but the lines. These are nothing but the lines. If I write y is equal to mod x plus 2, it becomes a straight line, right? It becomes a line here. These are my x and y axis, let's say. So now there is a transformation by 2 units. So you would put this graph out here. These are nothing but the lines. It's talking about 2 lines technically, that is lines. Hey, what if I write an inequality on this? It speaks about the region. If I change it here, y is greater than or equal to, whatever. Already I can write only greater than, I can write only equal to, whichever, or only greater than or equal to. Y is greater than or equal to mod x plus 2. If I write it here, now it talks about the region. If I make it greater than or equal to, it is now talking about all this particular region. It is talking about the region. Inequality talks about the region. Equality on this talks about the straight lines, line versus region. Let's be very clear on that, right? So whenever you find an inequality on this, you should be kind of talking about the region. Hey, same equation. What if it was y is less than or equal to mod x plus 2? What if it was mod x plus 2? Then I will be talking about the region below this. I'll be talking about the region below this if the sign is inequality. Okay, point. What is the point I'm trying to say? If you find equality, it talks about the lines. Mod talks about the lines. If you find an inequality, it talks about the region. Either region above the lines or the region below the lines, which we need to be little comfortable with. Okay, clear about the lines versus regions? Equation versus inequality clear? Everybody clear about this point? Because there was an inequality in that particular question. The moment you see inequality, you should recall what? Okay, now I'm referring to regions. Right? Immediately you should understand that you are referring to regions. You are not referring to lines. You are referring to regions. Good, very good. Coming back to this. That's one point there. That's one point. Inequality is referring to regions. Let's come back and draw these particular graphs therefore. Let's draw these particular graphs. If you draw this particular graph, the first one, let's call this as the first graph. When you are drawing this particular graph, there should be an offset of 6 units here. This is a unit 6, or an offset of 6 minus 6. Minus 6 is a mod graph. Of course, there is a scaling factor here. We'll come to that scaling factor later. First, I will minus 6. I'm drawing the first graph out here. Then since there is a scaling of 2, it becomes sharper. Therefore, it will not go with 6 versus 6. Rather, it goes with 6 versus 3. All right. Rather, it goes with 6 versus 3. This point is 3 and this point would be minus 3. In other words, when y is equal to 0, you can figure it out. Since the graph is greater than or equal to, I'll be referring to the region inside. I'll be referring to the region inside. This is what kind of ticks in your mind. There are two things. Hey, what if it was not 2? What if the graph was y is greater than or equal to mod x minus 6? Simply, my graph could have gone something like this. I will start with this minus 6. I will go to these points which are nothing but 6 and minus 6. My graph would have gone something like this. That's a difference. That's a difference. Scaling has brought it down to 3 and minus 3 kind of stuff. Fair enough. All right, now that's the point. That's the point. The moment you draw the graph, you don't have to get to the coordinates, etc., etc. The basics you should know, right? The basics you should know, and then quickly you will get to those points, the curves, the shape, etc. Okay, let's move to the second point. Let's move to the second point. Second graph. Let's get on to the second graph. Hey, what is this particular graph? Y is less than or equal to minus of. I can write this as minus of 2 mod x, all right, 2 times of mod x minus 6. Right, minus 6. Okay, it's, I already told you. Hey, this is nothing but what? This is referring to water image of this particular graph. This particular graph I already have in blue color. So I just have to refer to the water image of this. If I take a water image, it comes something like this. All right, it comes something like this. Right, this comes something like this, negative water image of this. We are looking at the water image. So this is the water image I'm talking about. So water image, that is, this point is nothing but plus 6 from here, because the mirror of this minus 6 goes to plus 6 and it becomes a water image. Fair enough. Now since solid it's a water image and there is an inequality less than, it again refers to the values which are inside. Already it refers to this particular value, and hence you are saying that, hey, I'm talking about the area of the rhombus. If you talk about this, hey, I'm talking about what? I'm talking about the area of this particular rhombus or 4 triangles. Either ways, I'm fine. This is nothing but the area of the rhombus, you could say, or you could call it as the area of the triangle. Say if this particular point is A and this point is O, this is O, and this particular point is B, 4 times the area of the triangle AOB. I'm fine with this as well, or you can directly find the area of the rhombus as well. Fine, let me find this 4 times of what is the area of the triangle AOB. It becomes half. The base is 3 units and the height is 6 units. Half base into height, right, which becomes 36 square units. Answer is nothing but B. Comfortable? Everyone comfortable, my friends? You're clear about the inequality, the water image on the graph? Clear about this? Is there a clarity in your transformations? Little bit of scaling has come in this particular question. Right? Very simple questions. All these are 1-minute questions once we kind of understand them. Right? But this understanding is very essential. That's my point. Because as we go deeper, if we fail to understand this, transformations becomes pretty terrible. Right? Simple questions, we make a mess. All right, here comes the another one. So here comes the another one. Very, very standard function. So all those who did 11th standard, answer this within a minute's time. Go ahead. I'll still give 90 seconds. Try and recall. All right, good, very good. All right, first let us come quickly to the basic of this. This is a very basic fundamental graph, isn't it? This is a very basic and fundamental graph. If I have mod x plus mod y is equal to whatever, let me call it as 2, right? Mod x plus mod y is equal to 2. Let me just write it as mod x plus mod y is equal to 2. What is the meaning of this? Basically, these are straight lines. These are 4 straight lines. It's an equation of 4 straight lines. It is not any region. It is just a straight line. Why? Because equal to, only inequality becomes a region. If it is equal, it becomes a straight line. Technically, it is 4 straight lines. You may wonder, what are the 4 straight lines? So you will have 4 cases. I'm sure your teachers might have said this. Hey, when x is positive and y is positive. Let me write that this is case 1. When x and y are positive, let me drop that particular line. When x and y are positive, you are talking already x is positive and y is positive. This is the line we are talking about, x2, y2, this is the line. But point is, if x is positive and y is positive, what do you mean? You also mean that this is true only in the first quadrant, and hence you only shortlist this particular portion. This is the meaning of x positive, y positive means the line lies in the first quadrant. X and y are positive means what? X plus y is equal to 2. Hey, what is the equation of the line? If you were to write the equation of the line, you will write x plus y is equal to 2. This is the straight line, x plus y is equal to 2. This is the straight line. But x positive, y positive, where? Where will be x and y are positive? Only in the first quadrant. Therefore, you shortlist only this portion of the line and discard the rest of the line. That is the meaning of this. Okay. Hey, what about the second one here? Case 2. X is positive but y is negative. That also can make me to call it x positive, y for negative, because it's a mod function. X can be positive and y can be negative. So how does it look like? X positive means this value, which is 2. Y negative is down. So therefore you are saying that, hey, this time my line goes like this. But x positive and y negative, x positive, y negative, which quadrant you are talking about? X positive and y negative is nothing but the third quadrant. We talk about the third quadrant, and hence we shortlist only this portion of the line. This is the meaning of this particular line, saying that x minus y is equal to 2. Hey, what about this particular line? This is x plus y is equal to 2. X minus y is equal to 2. What is the third line here? A third quadrant. Therefore, you say that, hey, C3, y negative and x positive. Y negative and x positive. Which quadrant? This lies in the second quadrant. Which is that line I'm talking about? All in x negative, all in x negative. Somewhere the point comes out here. All right, points come to here. Y positive, all right, y positive. All right, this is the line. This is the line I'm talking about. X negative and y positive. This is the line I'm talking about. That is true where? Only in the second quadrant. This is the quadrant. So this is the equation of the line. Minus x plus y is equal to 2. I mean, we need to have this clarity. We don't have to keep drawing this, but at least somewhere in the recent past, you should recall this. That's very important there. It is a set of 4 straight lines is an important fact. I'm just trying to show once, because time and again, when we do some other chapters on this, we will not write it. Okay, then there's a fourth one. Fourth one, both negative. Both negative means what? All right, it has to be quadrant 3. All right, quadrant 3, guys. I think this is a quadrant 4. I made a mistake there. Yeah, quadrant 3. All right, both negative comes in the quadrant 3. This is the line I am talking about. This is the line I'm talking about. What is this particular line? Minus x minus y is equal to 2. This is the line I'm talking about. Out of which quadrant 3 means what? I should shortlist this. And hence, it gives me a shape of a rhombus. If you technically look at this, these are the 4 lines which gives me a shape of a rhombus. And hence, when I say mod x mod y is equal to 2, your teachers would have said, hey, it is nothing but set of 4 lines which becomes a 2D diagram, the form of a rhombus. Clear, my friends? Everybody clear? Rhombus came to your mind. Your teachers would have said this as a rhombus, because what is the background? The background story is it is nothing but set of 4 lines, which is nothing but set of 4 lines shortlisted in particular regions. Comfortable? Yes, no, quick. Any doubts, any questions on this? Because it's a very basic question. Very basic question. Right? Yeah. Good. Very good. Very good. Now, this question is simply built on that particular premise. The question that we were doing was built on this particular premise. Let's take a look at this particular question. What is this? This is the first graph. What is this graph trying to tell me? This is giving me one rhombus. Of course, this is giving me one particular rhombus. Let's try this. Let's try this. All right, now let's try this. When x, all right, 6 or minus 6, mod x becomes 6 or minus 6, 6 here, or minus 6 here, 6 and minus 6. What about y? Y is nothing but 3 or minus 3. All right, y is nothing but 3 or minus 3. This is 3 or minus 3. This is the first line. These are the 4 lines. I have to shortlist 4 lines. I've shortlisted. This is for the first graph. This is for the first graph. This is what you kind of shortlist for the first graph. All right, what about the second graph? Coming to the second graph, you are saying second graph, you say this number 2 already is nothing but this, say, therefore you will say that, hey, this time x is nothing but 3. Already you shortlist these 2 points for x, and for the y you shortlist the points which are nothing but 6. Already you shortlist the points which are nothing but 6 and minus 6. So therefore you say that, hey, this time my rhombus looks like this. This is how the structure of the rhombus looks like. This is the structure of the rhombus. Guys, diagram clear? Diagram clear, everyone? Will you please quickly confirm that the diagram is clear? Diagram is clear to all of you? Diagram is clear, right? This is the diagram we are talking about. Out of this, what is the region? Region common. What is the common region? Of course, the common region is this. This is the common region we are talking about. All right, this part and this part. Right, this part. Of course, there is a symmetry and this particular part. And finally, this particular part. This is the common region I am talking about. This is what we need to figure it out. All right, this is the common region that we got to figure it out. How do we find this? Let me call it. So let's call only one portion of it. Let's find one portion of it, and then let's find the remaining portion. Let me call this point as A. Let me call this point as O. Let me call this point as B. Let me call this point as C. All right, let me call this particular point as C. If you want this particular point, let me call this particular point as D. Okay, one of you quickly tell me, how do we find geometry? We didn't do, doesn't matter. All of you would know some basic geometry. How do we find the area of ADBO? How do we find the area of ADBO? Can one of you quickly confirm on this? How do we find this area? How do we find the area of ADBO? How do we do this? Quick. Okay, Rishabh says perpendicular from D. All right. Perpendicular. Okay, so other way around is get the point of intersection. Great. I just wanted to understand that, hey, what is that your thought process out there? That is it. Okay, so I can also find this particular point D out here. I can also find this particular point D. It's an intersection. Point D is what? Intersection of this particular line. Do I know the equation of that particular line? Yes, I know it. What is the equation of this line? 2x plus y is equal to 6. Fair enough. Okay. Hey, do I know the equation? All right, that's the equation of that line. Do I know the equation of this particular line here? Do I know the equation of this blue line here? Yes, I know the equation of this blue line, which is nothing but x plus 2y is equal to 6. I can solve and I can find the point of intersection. Therefore, I understand that the D is nothing but 2, 2. If I know my equations, I can quickly find out what is that point of intersection. Once I have the point of intersection, I can find the area of the triangle IAOC minus, I can find the area of the triangle DBC. I can find the area of the triangle DBC. I will get the answer from there. Okay, what do you mean? All right, I will figure this out. What is the area of the triangle AOC? Half. AO is nothing but 3 units. AO is the height. AO is nothing but 3 units. What is OC? That is the base, which is nothing but 6 units minus half. All right, what is the height of this particular one? 2 units. That height is 2 units. All right, 2 units is the height. What is the base of the triangle DBC? The base is 3 units. All right, base is 3 units because the total length was 6, out of which O to B is 3 units. Therefore, the remaining is another 3 units. I could find this. Okay, therefore you say that this is 3 here. All right, this is 3 here and this is 9 here. 9 minus 3, 6 units. So 6 into 4. So my answer is nothing but 6 into 4 such regions. The multiple ways. You can drop a perpendicular. That is one way you can look at it. The other way of looking at this could be, hey, I have just 2 equations. Solve those 2 equations. You will quickly get the point of intersection as 2, 2. 2, means what? One of them is referring to the height. Another one is referring to the base. Either way, all right, use it and then you can check out just like 2 simple triangles. Triangle is nothing but base into height. I know the base, I know the height of this. So therefore, we'll be able to figure out the area. No big deal about it. Okay, all of you got this question? All of you got this question? There was a little bit of geometry also involved into this. But very simple elementary geometry, right? Very elementary geometry, no doubt. But major concept was 4 lines. There were 4 lines here. So very standard figure with 4 lines. Okay, all right, let's go to the next one. Now you find this out. If you have understood the story so far, try and do this particular question. Beautiful question. Try and answer this question. The whole idea of the previous study was to answer this question. previous studies to answer this question. I will give good 2 minutes. Try and answer this question in 2 minutes. Everyone try to answer this question. All right, guys, no worries. Let's do this. Let's do this. So what is this? Hey, again, 4 lines. What is the first graph talking about? This is talking about 4 lines. What is this graph talking about? 2 lines. This is talking about 2 lines. Mod x is equal to 5 is 2 lines. Mod x model minus mod y is equal to 4 lines. That is talking about 4 lines. And what is that? In the previous diagram, we figured out, hey, when it was a plus, listen to this carefully. It is nothing but modifying that, right? Mod x plus mod y is equal to 2. When I had this, you said that, hey, these are the 4 graphs on it now that we had intersecting like this, right? It was going like this. And there was a graph here and there was a line here. Now this is what we kind of said, okay, it is not looking ideal, but this is what we kind of spoke about. But then here, so that was mod x plus mod y is equal to 2. In this, we shortlisted this region. This is the region we shortlisted on this. When it was a plus, we shortlisted these particular portions of the lines. These particular portions of the lines is what we shortlisted. Now, I will go with the green ink. Now, listen to this. Mod x minus mod y is equal to 2, meaning x is ahead of y by 2 units. Even when y was 0, x is ahead of y by 2 units. In a sense, this time I need to shortlist these regions. X is ahead of y by 2 units. This is the region that you are shortlisting. Still you have 4 lines. Now let's assume this, hey guys, this is line number 1, but what portion of line number 1 I am interested in? This is the portion of line number 1 I am interested in. This is the portion I am interested in. Okay, let me assume that, hey, this is the line number 2. Say this is the line number 2. Which portion of line number 2 I am interested in? This time I am interested in, this is the portion of line number 2 I am interested in. Hey, if I say that, hey, this is line number 3, which portion of line 3 I am interested in? X is ahead of y by 2 units. I am interested in this portion of the line. So if I say this was my line number 4, which portion I am interested in? I am interested in this portion of the line. That's a point. Hey, we know this represents 4 lines. We know this represents 4 lines, but the point is we should be able to pick which portion of those 4 lines, which is very, very important, right? And the 4 lines, again, if you are confused, you got to do the same stuff out here. You have mod x minus mod y is equal to 2. Put x is positive, put y is positive. Then what is the equation you get? You get x minus y is equal to 2, and both x and y are positive. So you got to pick, in that, draw this particular line, pick in the quadrant 1. Plus means what? Quadrant 1. So if you are picking taking this, this is the line I'm referring to. This line is x minus y is equal to 2. This is the line I'm kind of referring to there, right? Likewise, you will get 4 lines. Once after this plus plus, what you do, x is positive, y is negative, draw another line. Likewise, you draw 4 lines, you will finally arrive at my hashed regions in the green color, what I hashed. That is what it kind of represents. I'm hoping that you are clear about this graph. Are you clear about this mod x minus mod y is equal to 2? I kind of tried to explain. Not clear, you may have to draw this. You may have to go through this ordeal. If not clear, you may have to go through that and try and figure out and get that mastery. Try and figure out and get that mastery, which is important. Which is important. No doubt it is important. Because it represents 4 lines. Which portion of 4 lines to pick is the choice. All right, that's a thought that we'll have. Okay, coming to the second portion. What is the second portion that we had? We had that mod x is equal to 5. The second portion we had is mod x is equal to 5. Hey, what is this particular point? By the way, this is 2. All right, this particular point is 2 units. What is this particular point here? This is minus 2 units. Okay, now this is 5 somewhere here. This is x is equal to 5. This point is 5. Okay, what is this particular line? This is x is equal to 5. And there would be another point 5 here. What is this particular line? This is x is equal to minus 5. Because mod x is equal to 5 means x is equal to plus or minus 5. So I have these 2 straight lines. So what regions I want? I want this particular triangle. I want this particular triangle. And this particular triangle, second triangle, this third triangle, and this fourth triangle. I want the region enclosed by these particular diagrams. This is what we are kind of interested in. This is what we are interested in. Fair enough. Okay. So let's figure that out. Therefore, let's figure that out. Hey, what are the region? Well, let's take one of the triangles. Hey, what if this is A here? And this is O here, let's call it as O here. And if I call this as B here, can I find the area of the triangle AOB? Yes, the base is 3 units. We know that this base length is 3 units. All you got to find out is, what is this particular height? How do I get what is this particular height? I know this particular equation, which is x minus y is equal to 2. I know this particular equation here, which is x is equal to 5. Which is x is equal to 5. From here, I will be able to get the point of intersection. I'll be able to get the point of intersection. Therefore, you say that, hey, y is nothing but 3 units. Solid y is nothing but 3 units. So you say that height is nothing but 3 units. Therefore, you say that half base is 3 units, height is 3 units. Half base into height. How many such triangles I have? I have 4 such triangles. I have 4 such triangles. Therefore, 2 times 9, 2 times 18 square units, which is the actual answer. 18 square units is the actual answer. Are you all getting this? Comfortable, my friends? Are you all getting this? What we discussed here? You're all comfortable. A little bit of area is there. Very simple. I'm doing it still in a very elaborative manner so that you all comfortably understand this. Are you getting this? Can I assume that you're all comfortable and getting this, what I'm discussing? Very, very simple graphs. Very simple graphs using the mod. Getting the clarity other than Rishabh and Sumit. Guys are getting the clarity. Multiple ways you can go by the slope also. Hey, slope is 45 degrees. Therefore, this will be 3 units height. Base is 3. Therefore, height would be 3. You can do it in multiple ways. All right, you can do it in multiple ways, no problem on that. Okay, I'm just taking one of the elementary ways, that is solving the equations. Equations is the most elementary way to do this. Okay, good, good. All right, try this. Everybody try this and get me the answer. Theta question. Theta question. Type in the answer. You got to type in the answer. Try, everybody try. Okay, all right, let's do this together. So what is that we are trying to do? Write it as an intercept form of a straight line. Intercept form of a straight line, in the sense you can write this, rewrite this first, kx plus, because you have to draw the graph, only then you will be able to understand this faster, isn't it? Kx plus 3y is equal to 12. What is intercept form of a straight line? X divided, intercept form of a straight line is this, x divided by a plus y divided by its intercept is equal to 1. This is the intercept form of a straight line. If I have to illustrate by drawing that particular line on the graph, it would look, if A and B are positive, assume that A is positive, assume that B is positive. They can be negative as well. Assume it is positive, Y positive, because it's given that K is positive and intercept of Y is already positive. Therefore, there is no worries on that. And then you say that, hey, if both are positive, X intercept would be somewhere here called as a point A. The y-intercept would be somewhere here called as a point B. This is the straight line I'm talking about. This is the straight line, x divided by its intercept being positive, y divided by its intercept being positive, which is B. Then how do I know? If I know the intercepts as A and B, this is how I have drawn this particular graph. And he says that, hey, if you know this, then the coordinate axis, then this is the area I'm talking about. Coordinate axis, x-axis and y-axis. Therefore, this is the area of the triangle author is talking about. Okay, how do I get to this? So first I will divide throughout by 12y, because if I'm writing the intercept form of a straight line, I should have my right hand side as 1. I cannot have any other number there. I should get my right hand side as 1. So therefore, I will divide throughout by 12 to start with. Let's divide. So you get this as kx divided by 12 plus 3y divided by 12 is equal to 1. Okay, but then I should have the coefficient of x and y as 1. There is no choice in the matter. Therefore, you write this as x divided by 12 by k. X intercept is 12 by k. Y intercept plus y divided by 12 by 3 is also equal to 1. So on this particular graph, what is the value of b? Therefore, 12 divided by 3 is nothing but 4. You have one value as 4. What is the x-intercept a? It is nothing but 12 divided by k. And hence I know what is my base, half area of the triangle, half. What is the base? Base is 12 divided by k. What is the height? Height is nothing but 4 units. Half base into height is nothing but the area given to me as 12 square units. All right, that is what is given. 12 and 12 are getting cancelled. Therefore, the value of k is nothing but 2. All right, that is the value of k. Comfortable? Everybody is comfortable, my friends. Basically, you are trying to make use of a little bit of coordinate geometry into the graph. You need to have that graph understanding. You need to have this basic background in your mind. This is the background. You need to have this basic background in your mind, and then map it with a little bit of understanding of your algebra, be it coordinate geometry, whatever it is. Be it geometry, coordinate geometry. You got to just mix up that little bit with this. Are you all learning something, making sense, everybody? All learning something, making some sense, what we are talking, right? Yeah, good. This sets the tone probably for our study. This sets a good basic, and then we will try and explore different graphs in the coming lecture. Right? We will try and do that. We'll try and do that. Quick announcements before we wind up what is coming up and what is next in the store. I will take a few more questions at a later stage, so as we go along. So we'll do more, explore a little more on the graphs. We will do that. What is coming up? Let me quickly explain this. Yeah, in the next coming days, that is 7th onwards, we will do a celebration series on DI. So I have chosen some of the good sets, and I'm trying, and we are trying to understand them. It will be a nice refresher, kind of like whatever you kind of know coming across the mocks. I'm sure it will reinforce your learning. Go through this particular course on 7th, 8th, and 9th. That is the next 3 days as we go through the celebrations of Dashera, etc. Don't be completely involved into the celebration affairs. At the same time, just have an idea, just balance between your celebrations, also a little bit of your prep. Try to balance it. And I've picked up some sets. So during this time, try and do the DI. When we come back, probably we will do a little bit of quad. This is what is in store on 7th, 8th, and 9th. Yes, we are also doing a small course on IIFT related course for about 6 hours. So those who have the subscriptions, etc., try and park these particular 1 hour each in the evening between 7 and 8, and we will do this particular course from 16th onwards, most likely on the alternate days. Okay, if you have learned something, okay, so kind of like it and then write your comments, whatsoever it is. And yes, I will try and see you guys as soon as possible. That's quick reminders from my side. to you. So yeah, any questions you can ask me now. This is your time. You can take 2-3 minutes and you can ask me the questions. Anything to ask, you can put it across now. Yeah, otherwise can leave and we can regroup some other time and do that celebration series. Yeah, Risha, we will continue. All the aspects we will kind of continue. We'll try and explore multiple things. Yes. So as much as possible, we'll keep doing for CAT 21. Yeah. We'll do that. Right. Yeah, any other question? Anything else? All right, thank you then. Bye-bye, guys. Okay. Logarithms, sure, Shivani. We will do it. We'll do on logarithms. We'll take it up. As a part of this algebra series, we'll take it up. Yeah. All right. Fine, that's pretty much done. So can wind up. So if you are done, any questions, anybody has any questions, you can ask me. We have about a minute or so. If there is a question, you can drop in, you can ask. If nothing, then we are good to leave. Yeah. Put your feedbacks whenever you get to the lecture. Once you do the lecture, drop your feedback. Yeah. Risha, we can try and solve the other questions also. There are a few more questions on the slide which we have not done. May not be on the graphs, etc., but you can try and solve them as well. Could be on maxima, minima, all that stuff. So because these notes will come to it, right? So you will have this PDF with you. Try and take a look, and some of them are previous CAT questions. You can try and do them as well. Okay, yeah, fine then. Pretty much that's it. So we will connect again. Bye bye. Have a happy season of celebrations. Bye.